Welcome back, Math 20-2. Today we are working on quadratic functions, and it's our very first lesson of it, so we're just going to review a bit on what we've learned in previous years about quadratic functions. So let's start out here. This one here is actually a linear function, and this is a quadratic function. Looking at these two equations, what is similar, what is different? First of all, I look at this, and this is multiplied. There's a multiplication here, 3 times x, and then plus 5. So 3 times any number we choose plus 5. I look at this one here. It is any number we choose multiplied by itself plus 4. So both of these have a multiplication and an addition. That's one thing those are two things I like. Both have multiplication, both have an addition. What is different? Well, this one here is being multiplied by a constant. It's just being multiplied by 3. Whatever number we choose is multiplied by 3. This one here, it changes. Whatever number we choose, we multiply it by itself. So we're always changing what numbers are being multiplied by. So this one's constantly changing with the multiplication. There isn't a constant. The second part here, it wants us to compare these two equations through a table. Well, this first one says we have 3 and we multiply it by any number, then we add 5. So let's try when x is negative 3. So negative 3 times 3 is negative 9 plus 5 will give me 4. Negative 4. Negative 9 plus 5 gives me negative 4. The next one is negative 1 multiplied by 3 is negative 3 plus 5 will give me 2. Then we have 1 multiplied, because 1 is the value of x, multiplied by 3 is 3 plus 5 is 8. Then I'm going to have 3 in for x, so 3 multiplied by 3 is 9 plus 5 is 14. And then my last one here is going to be 5 multiplied by 3 is 15 plus 5 is 20. Okay? If we notice this, it's kind of interesting. There's always a difference of 6. There's a difference here of 2 and here of 6. We have a steady difference. Okay? If we go up by 1s, we would have gone up by 3s. Now let's take a look at the next one. We have x squared. Now, if I square a negative number, negative 4 times negative 4, that gives me 16. So we put a negative 4 for x. Negative 4 squared is 16, plus 4 is 20. Negative 2 squared is 4, plus 4 is 8. 0 squared is 0, plus 4 is 4. 2 squared is the same as negative 2 squared. That's equal to 4, plus 4 is 8. 3 squared is 9, plus 4 is going to be 13. And 4 squared is the same as negative 4. Then we add 4, we're going to get 20. Okay? Now if I look at this kind of makes a neat little shape. Look how the negative 4 and the 4 are even, the negative 2 and the 2 are even. It's kind of interesting. So the next part wants us to graph. Now in order to graph this, we're going to look at our table beforehand. We're going to use that to help us graph. So it says when x is negative 3, y is negative 4. So when x is negative 3, because we're first graphing this one, when x is negative 3, y is negative 4. Then it says when x is negative 1, y is negative 2. So when x is negative 1, y is, positive 2. Next one here is saying when x is 1, y is 8. So we'll go to 1, and I'm at 8. The next one here is when x is 3, y is 14. So go to 3, y is going to be 14. And then it says when x is 5, y is 20. And I connect these lines here. And I should get a very nice straight line. So it's a nice, perfect straight line. It's very linear, very straightforward. So we get the term linear. The next one is going to be a little bit different. So take a look at this next one here. I'm just going to flip the page so I can see the data better. So it says, when x is negative 4, y value is 20. When x is negative 2, the y value is going to be 8. 8 there. I put 2 over 8 up. When x is 0, the y value is 4. When x is 2, it is 8. When it's 3, it's 13. So I'm just going to roll it over. Oops, 13 is right there. And when it's 4, it's 20. So there's that. Now if I connect this graph is going to look like this. So this here is my quadratic function, and it makes a graph that looks like that. This is called a parabola. So in which ways do the graphs look alike, and which ways are they different? Well, there's not much similar. This one here is a parabola, this one curves, this one's straight. They both do go on forever. This one goes on forever this way and forever that way. Both go on forever in my x. I will go forever that way. Both of them go forever this way and forever that way. The quadratic, though, has a limit on its up and down. It goes forever in one direction, but not both. So these are very interesting things. The quadratic curves, the linear doesn't. Okay. So the next part here is it wants to state the domain and range of x for both. So state the domain and range of this one. Well, for my first one, my linear, my domain is x is an element of all real numbers. Okay, it could be everything. We have unlimited. My range is y is an element of all real numbers. Okay, and we're using y such that y is an element of all real numbers. Now let's take the domain and range of this one here. So first my domain. If I take a look at this graph, I go forever left and forever right. So my domain, we have x such that x is an element of all real numbers. Now let's look at my range. In my range here, the minimum I have is 4. So my range, y, must be greater than or equal to 4. And we're looking at y such that y is greater than or equal to 4. Oops, sorry, I kind of ran out of room there. So it's going to look something like that. Okay, now it says the range of the related, oh, so I did both the domain and the range together. Alright? Okay, so here we're going to now go onto this part here, and we're going to try and figure out what each of these look like. Graph each of these in your calculator, okay? Do not list the x and y intercepts, just graph each of these in your calculator. So if I look at this, every time x goes up by 1, my y is going to go up by 3 and plus 1. So it's going to look something like this. Okay? Let's look at this next one. If I graph this one in my calculator, what's that going to be? Well, if there's any time a squared, we're going to have something called a parabola. It's going to make a U shape, a happy face or a smiley face. If it's negative, it's going to be a sad face because it's negative. If it's positive, it's going to be happy. So I look at this one here, and this is going to look something like this. Okay. Now the next one here, we have a cube function. Well, what does that look like? Graph in your calculator, and you're going to get something that looks like this. Okay. Next one is squared. I'm going to get something that looks like this. Oops, sorry. This one's a negative, so I'm going to have to go down. This one's like that. Sorry, I made a mistake. The next one here, it's a reciprocal. That's a bit different. Is that really quadratic? No, that's going to look something very different. It's going to maybe look like this. This one's going to look something like that, as my asymptote is 0. Okay? The next one here is going to look like, as we go closer to this one here, x squared is going to look like this. If we go this one, it's like this. So now I want you to just fill out all of these here. Fill out the rest of them. Just graph in the calculator, fill out the rest. So it says list the equations of the graph in the appropriate row. So which ones are linear? So which equations here are linear? The linear are the ones that just have an x. Okay, so this will be linear as well. This here will be linear. Which of the equations are quadratic? Quadratics, circles, are going to be my box ones. Okay. Now which of the equations are neither? Those are all the rest. How can you tell the equation functions whether it's quadratic or not? Well, if it's quadratic, it must have an exponent of 2. It has to have a squared exponent, okay? And that has to be the highest exponent it has, and it has to have a squared. So here we go. Class example number 1. It says, without using type knowledge, identify which of the following functions are quadratic. So identify the following functions. Okay? So we want to know if it's quadratic or not. A is going to be a quadratic. Okay? This one here, well, this is not quadratic. This next one here, well, I have an x squared. There's nothing with fractions, so this one here is quadratic as well. Okay? So next one wants us to figure out which of these here are quadratic functions. Well, this is a complete circle. This is not a quadratic function. Okay? And if you remember in grade 9 or grade 10, you also did a straight line test like this, which we'll get to quite a bit later. If it goes the vertical line test, if it hits both, it's not a function. It is a relation. Okay? So we want quadratic functions. Is this here a quadratic function? Yes. It's curved and it makes a happy face. So quadratic functions normally make a happy face or a sad face. That's it. So this one is a quadratic function. This next one, well, that's a sideways face, so this is no. This next one here, yes, it's a quadratic function. It's making a sad face. Okay? So that is the whole lesson. Tomorrow we'll work on this, just getting the definitions as I see you tomorrow. Good luck.